And the frequency was 76 and 60. And then B naught, they'll give us a B naught too.
No, and the one thing with the frequency, you gotta do 2 pi times, so it's like 1 gigahertz, you gotta do 2 pi times. Also, I'm putting the camera here, and I put it in there when real more convenient.
These that I throw down there remind me to throw out. All right, so any questions about the homework? Anything? I got some interaction about it, and I try to respond. You sent me something I didn't quite understand, but I don't know, 2 or 3. Hunter sent me something. Are you here? Is Hunter here? Oh, there you go. You sent me something. A couple other people had different things. I hope you're interacting with each other. But anyway, did you have a question? This is about minimizing line links, either from the load to the attachment point of the stub, minimizing that, or minimizing the stub link. Go ahead. Which? I'm going to do at least one, maybe 2. You got one for me, anybody?
Yeah. I just kept getting a different answer than the answer you had uploaded on the OneNote. And this is for 2.38.
All right, so I'm going to ask you to all do this with me. Get a fresh Smith chart. Let's make sure we know what we're doing, all right? Get a compass and get a straight edge, and let's do it together. So my Smith chart is not your Smith chart, obviously. But let's try to do this. When I draw these things, I always put the one circle in here. And let's see. It's going to start. It's going to have some load. Either unknown or known, some Z naught. And go ahead from there.
Okay, so the Z load is 200 plus J 160. And then Z naught is 100 ohms. And we're supposed to be finding the solution that minimizes the length of the shorted stub.
Okay. Shorted stub? All right, so they're attaching a stub here that's going to have a short circuit, and this is L stub. Are you with me, everyone? Okay. Now, we're going to minimize that length, right? So I want you, before anything else, to listen to me. If we're minimizing that length, we have to think about one thing. When we have a shorted stub as such, right? This has an impedance equal to 0, or a normalized ZL equal to 0, and that means a normalized YL equal to infinity. You all follow me on that? Everybody? How many do? I want to make sure, because sometimes people they don't know what I'm talking about. ZL is 1 over YL. YL is an admittance. We're putting this stub in parallel or shunt, so we work in the admittance domain. You all clear on that? All right. Now, if you look at this, it's infinite, right? YL's infinite. So if we just look at the stub and see where we would come in at, we would come in right here, right? You all agree with that? That would be your entry point for the stub's load admittance. Now, as you move, you can see these are minus J something. You all see that? That would be the shortest distance of the stub's length. Starts out being negative J, right? So we want to land on the one circle where it's positive J. You all hear me on that? How many understand that thought? All right. So now we've got this. So we're going to do the whole thing right now. All right. And this should go fairly quick. So if this is ZL, normalized ZL is going to be what? 2 plus J 1.6. Do you all agree with that? That's going to be, 2 is about in here, 1.6 is about here. So if I look at that, I'm gonna say it's about, probably here is ZL. Can you all confirm that? Everybody, can you all see that point? 2 plus J 1.6, about. That would be 0.1. Now, if you draw a line straight through that, go here, and you draw a circle around there, a constant radius, in other words, this would be constant gamma, right here. Then you're going to come to the conjugate point. I call it conjugate point. This is YL. It's 1 over ZL, right? Yes, sir.
So where you drew the center point, that's not the one circle, that's the circle that ZL is currently on.
Yeah, that's just 2. I'm just trying to show you how I'm estimating that. That's about 2. This is about J 1.6. And it's just, you know, it's rough drawing here, but it's to give you an idea. Y'all with me? Can you see it way back there? It amazes me how people in the back that far away can see this, but I'm glad you can. Because your eyes are a lot better than my eyes. All right. So now if we have that, the next thing we need to get, right? Y'all follow me? Is this. Wavelengths towards generator. We're at the load. We can only go towards the generator. So what's that? Can you all look at that and just estimate that?
0.46.
He says 0.46. Is that about right?
Yeah.
It's going to vary a little. 0.46 lambda, right?
Mm-hmm.
Hear me now. Now, here's where we are. We're going to move towards the generator, so we're going to move in this direction until we hit this 1 circle. So this is going to be 1 plus J something. This is 0.2. This would be 0.3 right here. Y'all agree with that? Right? And it's going to be, I'm sorry, not that, right here. This is 0.3 right here. And so what is that 1 plus J? Can you just estimate that? Say again? 1.3? How many got 1.3? Take a careful look. If you didn't, don't be afraid to say, did you get 1.3 down here or not? You didn't, what'd you get? Or you don't have yours out, never mind. I thought you had a Smith chart.
Sir, I'm not getting 0.46 doing it that way.
What do you get? Are you looking at outer rim wavelengths towards generator?
So I'm going from ZL,
No, I mean right here. Are you looking at wavelengths towards generator?
yes.
And what do you get?
So if I'm doing it that way that it's drawn right there, I'm getting like 0.394. Unless, is the intersection where you're drawing the straight line, is that going through the
This
center of the
goes from
Smith chart?
ZL right through here, right through YL, and it's coming right out here. So this should be a straight line all the way through.
I'm still getting 0.394.
Can you, Nick, can you get over here? Sure. See what's going on? Yeah.
Yes.
Is that going, that line from ZL?
Say it a little louder.
Is that line from ZL, which is to the other side, going through the origin of the?
Yes, through the center.
Okay, you have it drawn through the.
Okay.
Oh, I'm sorry. Here.
Okay. All right, that makes more sense.
If I hold it for 1 second. I don't mean to confuse you. I'm confusing myself, I think.
It's 1.2. Yeah.
Let me just try to draw this again. This is a 1 circle.
I got like 1.4s too, so it's no.
I said the load was about here. This is ZL. If I take a line, I'm sorry about that. If I go right through the center here, he tells me I'm getting about 0.461. Is that right? Wavelength 0.461 lambda wavelengths towards generator. Is that right? Class, how many see that? Are you straight with it now?
That's
I'm
fine.
sorry about that.
That's
There's my fault. But it should go through the origin. This should be YL over here. Now, make sure you draw this circle. This is a constant radius from here to this point. It's constant gamma here. Now, when you move from this point, you're going to move here along this trajectory, and you're going to come to a point. I guess it's 1 plus J 1.3 from what I heard. This would be 0.2. This would be 0.3. Right? Y'all follow me on that? 0.3. Now, then you make sure you do this. Go from the center of the circle, draw a straight line right through there, and you're going to have something wavelengths towards generator. Can you give me that value?
0.172.
0.172 lambda. Anybody confirm that? Now you're going to get some difference, I guarantee you. Because your eyes and your, everything's got a little error in it, so you're not going to get exactly that all the time. Now, the next thing we're going to do is find the length right here. This is going to be L, and they call it L through. Doesn't matter what you call it. So the way we get it is, we take the point we landed at, which is 0.172, minus the point we came from, 0.461. And I know that's negative, so I have to add a half wave. Y'all follow me on this? Anytime you got a negative value, you add a half wave on to it. So it's going to be 0.5 lambda. And what's this value?
0.212.
0.212? About right? How many got that? All right, 0.212. So that's the distance that I move. By the way, on this quiz, what I'm about to give you, please draw this and then list the distances there as well as putting them in the spaces provided. Y'all hear me on that? And you can use your own Smith chart, so get your own Smith chart out to do the problem. And then I've got a stapler up here, staple it in the back. If you don't have a Smith chart before the quiz, raise your hand, we'll provide you one. I'm sure people have extras. Okay, now for the stub length. You see how this is J1.3? We want to add to it minus J1.3. Does that make sense to everybody?
Yeah.
So if we start from here, at this point, these are like minus J a million kind of thing here. Keep going down until about here, you're going to find J1.3. It's minus J1.3. Can you all find that on the red? Make sure you can. Can you all see it? Back there far? Can you all find it on your Smith charts? Trust me, just finding this stuff is a big deal for some people. Their eyes aren't as good as, I guess, some of yours. All right, now, draw a line right from here through that point, from the center, and then tell me what the wavelengths towards generator are at that point.
Got 0.355.
Anybody confirm that? 0.355?
Yeah.
Now that isn't the distance, and what people will do is say it's 0.355. It's not. You started here. You all follow me? That's 0.25. That's where you started. So your actual movement is 0.355 minus 0.25, which is going to be 0.105 lambda, right?
Yeah.
So this is going to be, L stub is going to be 0.105 lambda. Y'all follow me? I'm going to say this. If it was an open circuit stub without minimization, if it was an open circuit stub that you want to just cut and replace that with, then you would have to go, if you think about this, right? If it's open circuit, you start here, don't you, class? I mean, open circuit has an impedance of infinity and an admittance of 0, correct?
Yeah.
You would start here, you would add an entire quarter wavelength to that one. You all follow me? Yeah.
Wait, when going from the 0.355, what do you subtract from it?
You enter the actual, if you're right here, right? The actual admittance right there is going to be infinite, isn't it? ZL is 0, so the admittance is infinite. That means the infinite admittance point is right there. That's where you enter for the actual stub, right? You move, that's 0.25. Take a look at your chart.
Yeah.
You move to here, so the distance you move is 0.355 minus 0.25. Right?
Oh, I see what I did. Okay.
Right. Yes, sir.
How come we don't go at J1.3 where it intersects with R?
Because remember, if you have a stub and it's short, right? The impedance is 0. The admittance is infinite, right? The infinite admittance point is right here. There is no other point. That's where you start. And you move from the actual value of the stub's admittance until you have minus J1.33. That's it. And by the way, when you have either a short or an open, you just have imaginary values for impedance or admittance as you move away from there. Yes, sir, in the back.
If the question only asks for the length of the shorted stub, is there any reason we should calculate the through line length?
Yeah, because you have to know where to attach it if you're building this thing. You can't just put it.
At the one circle?
What, ask that again, maybe I misunderstood.
Wouldn't it just be at the one circle? Like you plot yours?
Yeah, but look, you don't know what this distance is, right?
No, but the question is, like, if it doesn't ask you that one, you.
Well, I'm saying in the real world, I'm gonna ask you that,
Okay.
so you're gonna have to know that. You have to know where you're located or else the thing doesn't work. Y'all follow me? I'll ask that.
Would the through distance be the same for an open circuit stub?
Now, it all depends on how the question states. If they want the minimum distance of the stub, right? Then it's different for open versus short, right? Because for an open circuit stub, if this was an open right here, the impedance is infinite, the admittance is 0, right? If you're 0, this is your 0 point, right? So if you're at the end of the stub, I mean where the stub open is, here's where you start. These are positive J values, right? So we would want to land on the minus J circle in order to minimize the length of the stub, right? Because y'all following me in the reasoning behind this, right? Depends what you want to minimize. If you want to minimize distance to connection point of stub, then it's wherever you come in, what's the minimal distance to hit either this or this, right? If you're inside here, you're going to hit this point. It's going to be 1 minus J something, right? If you're outside here, you're going to hit 1 plus J something. Y'all follow me on that, class? Okay, it's just being familiar with the Smith chart. Another question? I'm trying to do this as best I can. Yeah.
So if you're trying to minimize, so you said if you're trying to minimize the distance, you're gonna go to whichever.
What distance?
The distance that you attach it, sorry.
All right, attachment point, it's real easy. All right, you come, and it depends, is it a shunt or is it a series? You want to do shunt parallel?
You just shut, yeah.
All right, so if we take the same problem, we want to minimize the distance to the connection point of the stuff. You follow me? In other words, the through distance from here to here. Then what you do is start here, and we'd still go to this point. That would be the shortest distance. You all follow me? Everybody?
Yes.
Okay, that's still the shortest distance. If we were in here, if our YL was in here, then this would be the shortest distance. It would be a negative change. You all follow me on that? So that's the idea. Okay, another question. Yes, sir.
Yeah, so that's what you do if you're trying to minimize the distance. So if you're instead trying to minimize the shunt length, would you, instead of doing that, would you start with the shunt length and then?
Whoa. Say this again. You're trying. What are you trying to minimize?
The shunt length.
All right. Well, that's what it is. But it depends if it's shorted or if it's open, right? If it's shorted, you do it the way I just did it. If it's open, then the shunt stub starts over here, right? And your first values you get is you add a little bit of distance or plus J, so you would have to end up on the 1 minus J, because the plus J minus J will kill each other.
Okay, so.
Y'all with me on that, class? How many understand this idea? All right, you okay with it?
Can you say that again?
If you have a shunt stub that is an open circuit has an impedance of infinity. 1 over that would be the admittance, right? It would be 0, right? So if you have a shunt stub, your admittance starts right here. If this is an open circuit, this is where you'd be, correct? Now, if you add any length to that, it's positive J, correct? If you positive J, it tells you right away, for this to be a minimum distance, you're going to have to land on this part. You have 1 minus J something, because you're going to add a plus J. You want it to be a minimum distance, so you want it in this from somewhere less than a quarter wavelength. Y'all follow me? How many understand this idea? You follow me in the back there? Or
Do we have time to do one like that?
say again?
Do we have time to do one like that?
Yeah, pick one. I mean, or you just make up a problem, do it. Or find one you want to do, because it really comes down to your understanding of the Smith chart. Yes, sir.
So just using, like, assuming you're trying to minimize.
I think
the length
2.41
of
is
the stub,
Yeah.
does whether you use short or open entirely depend on whether the load is bigger than the
No. Listen,
transmission?
where you land on the 1 plus or minus J circle is dependent on the type of stub. If you're trying to minimize the length, right? If it's a short circuit stub, then your values, and this is assuming in parallel, your values would be negative J beginning, right? So you want to land, when you go from the load, you want it to land on the 1 plus J. So the plus J and minus J will kill each other off. You all follow me?
Yeah, like you would have to be outside the one radius in order to get to the 1 plus j part.
When you land, if we're doing parallel, all right, shunt, you're going to be in a y domain, correct? YL, correct? All right, so if your load's here, right? Now, you have 2 points you can hit, here or here, the conjugate point, right? If it's an open circuit stub, it has a YL of 0, a load value of 0, correct? So you're entering here for the stub. So as you move up, you have positive J, right? If you want this to be a minimal distance, then you want to make sure you land on the 1 minus J when you move from the load all the way around, because this will be the shortest distance. It'll have to be a plus J, so the load will have to have 1 minus J. Do you make sense, Tanya? That's it. If it's a short circuit stub, then you start over here. And the first values are negative, right? From the load, if it's a short. That means you want to have 1 plus J, something that you land on from the load. So when you add the minus J to it, it kills it off into minimum, right? I hope you understand what I'm saying. I'm not using a whole lot of precise words, but I'm trying to indicate when you're thinking minimum, think of the type of stub, open or short, and is it in series or parallel? Parallel in Y, if it's series, it's impedance. Go ahead.
Didn't you say that you would, in the real world, kind of advise using stuff?
We would use short in the real world, almost always, because an open circuit stub has an electric field between the plus and minus open ends, and it can infect other components and cause problems. Yeah, it can bleed over.
You do 2.42?
Yes.
Load is,
Wait, let me just erase this first. By the way, did anybody get that Smith chart tool that I sent you working on the old Explorer? Anybody? That's an incredible tool. It'll do any kind of matching you want. It'll do it with impedance, with L's and C's. It'll do it with transmission lines, short or open, in series or parallel. Yeah.
Alright, so if we stub length, if there's like a minimum maximum, is stub length just a range?
Is what?
Is stub length like a range you can choose from for the circuit to work?
You fabricate it. You literally put lithography on there, and then you'll build it with, usually this stuff's done with Droid board, where you fabricate the whole thing. And the reason they use stub lengths is because they're easy to build. Putting components and capacitors costs a lot more money, but stubs are easy to do. All right, 2.42, who said this? 2.42?
alright, you load 70 plus J 110.
All right, so I got Z load 70 plus J 110.
Z naught is 50.
Z naught equal 50. Go ahead.
Choose a solution that minimizes the length of the through line.
Yes, it's short or open. Or,
Open-ended. Open-ended shut stub.
okay. Well, through line tells me everything. So what they're saying is they got a stub, it's open right here, right? It's got some Z naught, some stub length, L stub, right? Now, he says minimize the length of the through line, and we're assuming it's in parallel, right? I think he says shunt. Shunt is parallel. So here's here's my Smith chart, the old Smith chart. So ZL is going to be what? It's going to be 70 plus J110 over 50, right? So that's equal to 1.4 plus J 2.2, correct? Class? You with me on that? All right, so where is that? So 1.4 is somewhere inside the one circle, 2.2 is up here. So if you track this, yeah, I'm going to say it's about here. That's my ZL, right? Correct, class? Now go ahead and take your compass. Might as well do this right now, and just make a circle with that of that radius. That's the constant gamma circle. Not a very good circle, but nevertheless, Then draw a line straight through there, through the conjugate point here, and this is YL, correct? Now I'm going to show you something. It doesn't matter what kind of stub you have. If they're asking for the minimal distance of the through line, this is how you do it. You all with me? All right, so there's going to be something here called wavelengths towards generator on the outside. What do you get for that value, anyone?
0.448.
He says 0.448. Anybody confirm it? Can you all see it back there, guys? Take a moment. Look. Yeah, all right. You're going to get that kind of slop. It just happens. You got air building up, lead, you know, your compass isn't perfect, everything. Smith chart probably has. So 0.448, did you say? 448 lambda. Now, that's where I get, right? How far do I have to go? I'm going to go all the way around until I hit what? 1 plus j something, right? With me on that? What's the value for that, just to be complete?
I got like 2J.
2J? What?
You just want the reactive value?
What, 1 plus j what? 2, 1.9, about
Yeah,
that?
1.9.
All right, so it's j 1.9. That's fine. Now, shoot a line right through there from the center and tell me what the blank wavelengths towards generator is.
1.86. 0.1.86.
0.186. Anybody confirm that? Take a moment. I mean, if you do these things with me, it'll save you so much anguish. Trust me on this one. These will drive you nuts if you don't do them. Y'all with me on that? All right. Now, what's the distance I went from here to here? It's less than a half wavelength just by looking, unless I drew it wrong. You all agree with that? So what is it going to be? It's going to be this point, 0.186 minus the point I came from, which is 0.448. But that's negative, so I add 0.5 to it. And what's that value going to be?
0.238.
Sounds right. 0.238 lambda. Anybody confirm that? Y'all get that?
Yeah.
All right. That is the minimal distance. I don't care anything about the stub at this point. That's the minimal distance from the load to the attachment point of the stub. Is that correct to it? Is that what he got? Huh? I mean, there's a solution I put up there. Can anybody confirm or deny that? It's the right answer, I'll tell you that. I don't care if it's right or wrong. He's got 0.237. That's right. Now, I want to say this. For the stub length, how would we get it if it's a short circuit? Short circuit stub. I've got what? I've got J 1.9, correct?
Got a negative.
So, with a short circuit stub, where do you come in on?
Right
Right
side.
here, right? If it's an admittance, correct, class? How far do I move?
Negative 1.9.
Right, minus J 1.9 here. And I don't know where it is. It's going to be about here. So if you shoot a line through there, we might as well do this. What's the value? Y'all follow me what I'm doing? That's where I started. I'm measuring this distance now in a second. What's that?
0.375.
Wait,
Point what?
No, I made a mistake.
0.32.
0.32 what?
7.
7 lambda?
Yeah.
So what's the distance? This is 0.25 lambda, so the actual D stub, the stub length, or L stub, is going to be equal to
0.107.
0.32, 0.327 minus 0.25 lambda, what's that?
0.07.
All right, now that's less than a half wave, or less than a tenth of a wavelength. I'm going to warn you about this in the real world. I'm not going to sting you on quizzes. In the real world, when you're less than a tenth of a wavelength, it starts to not act as a transmission line. It looks like you're just shorting the thing out to a short, which is 0 ohms. You all follow me? So normally, in the real world, if you want to make sure this thing works and you don't want to kind of rough it, add a half wavelength. So that would be 0.577 lambda. Do you hear me on that? Add a half wavelength, then it'll all work fine. But I'm warning you, in the real world, don't ever get less than a tenth of a wavelength and assume that thing's going to behave right. It'll start very rapidly looking like just a piece of wire. So that's what you gotta watch out for. Yes, sir.
I thought since it's open, you wanna go to the 1 minus J 1.9.
Say again?
Since it's an open stuff, I think you go to the 1 minus J 1.9.
It's not open, it's short. Oh, sorry, I did it for short. So if it was open, what would I do?
Left
I
side.
take that distance and add a quarter wavelength. I'm so sorry. I meant to do it with
Wait,
short.
can you do that part?
Huh?
Can you do that part?
What?
If it was a open?
If it's an open, it just goes from here, which is 0, right, to here. So it's just 0.327.
Oh, interesting.
Y'all follow me on that? It's kind of nice that way. All right, anything else?
So basically, we just get to that 0.327 and then
Say that a little louder.
we just get to that 3.27, then if it's an open or short.
If it's an open, it's just 0.327 in length, because the open starts right here if you're in the admittance domain, right? Now, if you're, I don't want to confuse you. If there are series circuits, if there are series elements, you stay in the impedance domain. You don't go to the admittance domain. Y'all hear me on that? And some of this gets a little confusing. All right, now, technically I got 20 minutes, but I almost feel like I'm going to give this to you for the quiz. Would you do me one favor? Make sure at least one, preferably 2 open desks or seats are between you and your nearest neighbor. And try to spread out. I'll spread you out if you don't. And I'll give you a quiz now. And I hope you have a good weekend. But on Monday we're going to go through bounce diagrams. So if you want to read that.